All right, so if it says solve by any method, what would be one approach you would take? If this was on your test, test number 2, what approach would you take? Say it again? Okay, so X is already by itself. So tell me you've only learned of 2 methods to solve a system other than graphing. What are they? Substitution, and the other one is elimination/addition. So if you're told solve by any method, tell me what approach you want to take. You want to do substitution? Okay, so let's do substitution. So in order to do substitution, you got to pick one of those equations, and it doesn't matter which one. You can do the first one or the second one, it does not matter. But which one would be more efficient? The first one. Why? Because the variable x is already by itself. All right, so in the first equation, all right, so we're going to do this one by substitution. So if I do this by substitution, the variable x is already by itself. Now once I solve for a variable which x is already by itself, remember I circled this expression right here. What then did I do with that expression I have circled? Substitute into the other equation in place of what variable? X. So I'm going to go here, substitute it here. And so I get 2 times, in parentheses, what do I put in parentheses? 3y plus 6 minus y equal -3. All right. So now I've got to solve this equation that only has one variable in it. So what's the next step? Distributive property. So I get 6y plus 12 minus y equals a -3. Then what? Combine like terms. So I get 5y plus 12 equals -3. Oops, -3. Then subtract 12 from both sides. Combine like terms. I get 5y equals a -15. All right, then what? Divide both sides by 5. And so I get 5 to be -3. So I found the y coordinate of the solution to this system. How do I find the x coordinate? Substitute it back into this equation right here. It really doesn't matter which one, but since x is already by itself here, then plug it back into this one. So then I get x equals 3 times y, which is -3, plus 6. So 3 times -3 is a -9. -9 plus 6 is -3. So in terms of an ordered pair, what's your solution? -3 comma -3. All right. Now, remember, we solved this by substitution. If someone wanted to use the elimination, so let's do it by elimination. Okay, so elimination/addition. So I'm going to go back and we'll go ahead and rewrite the system again. All right. So if it says solve by elimination/addition, then what is it that you have to do? What's the first thing you have to do? Say it again? Line up the variables. So you got to bring all the variables to one side, the constants to the other, and make sure the x's are aligned and the y's are aligned. So that means I'm going to have to rewrite this. And the first equation, I'm going to have to write it as x what? -3y equal 6. And the second equation is going to stay as it is. All right. Now, when doing this by elimination addition, remember the whole idea is to be able to add those 2 equations, hence addition, and one of the variables will be eliminated. Right now, if I add those, nothing is eliminated. So what we talked about was that if I want to eliminate the the variable x's, then the coefficients have to be opposites of each other. If I want to eliminate the variable y, then the coefficients have to be opposite of each other. It does not matter which variable you eliminate. If you want to eliminate the x or the y's, it does not matter. Which one do you want to deal with? Okay, that's not my question. Which variable do you want to eliminate? The x's? Okay. So if you want to eliminate the x's, then these have to be opposites of each other. So what's the LCM, the least common multiple of 1 and 2? 2. So that means I need both of those coefficients, one to be a positive 2 and the other one to be a what? Negative 2. Well, since this one's already a positive 2, then I'm going to multiply this one by a what? Negative 2. So multiply both sides by a negative 2. So every term is going to be multiplied by negative 2. So then I'm going to get this system. What's going to be the first equation? Plus 6y equal negative 12. And I'm going to go ahead and just rewrite the other one. Now what do I do? You got to say what word first? Add. Add them. Remember, I always put the word add here. I add them. So when I add them, then one of the variables will be eliminated. In this case, the x's. So the x's are eliminated. When I add them, 6y and a negative y is 5y. A negative 12 and a negative 3 is a negative 15. All right, so that's just what we had here. Remember when we did about substitution? Right here? All right, divide both sides by 5. I get y to be a negative 3. All right, now once you find your y coordinate, you've got to substitute that value into the value for y into one of those equations. It does not matter which one. Always go back to the original system. So since y is negative 3 and x is already by itself here, I'm going to go ahead and use this one. So now we're going to substitute into first equation. Again, it does not matter which one you substitute y into. You just got to solve for x. So remember, you got to solve for x now. So I get x equal 3 times y. What's y? Negative 3 plus 6. So that's negative 9 plus 6, which is negative 3. So there's your x value. If you want to use the second equation instead, you would still get the same thing. Notice what you would get, though. You would get 2x minus y. What's y here? Negative 3, in parentheses, equals negative 3. So this becomes 2x, subtract negative 3 becomes what? Plus 3 equals negative 3. Then subtract 3 from both sides. I get 2x equals negative 6. Divide both sides by 2. Notice I get x is still what? Negative 3. So it does not matter which equation you use. Okay? So the solution as an ordered pair is going to be negative 3 comma negative 3. All right? Okay, so we did this system two different ways. One by substitution, the other one by elimination / addition. If you had this one, number 2, let's say you had 2x minus y equals 7, and then 6x minus 3y equal 14. And let's just go ahead. That's a 14 right there. Let's just go ahead and do this one by elimination / addition. So solve by elimination. / addition. All right. So again, when solving by elimination / addition, the variables have to be aligned. So the variables aligned here. Yes?
All right, I just saw that on my papers. You said Thursday, 6:30 today.
Nothing. What?
Sorry, 8.1.
Okay. So what? I forgot where it was.
We're gonna eliminate.
Okay, we're gonna do this by elimination. So the variable's already aligned, right?
Yes.
Okay, so when doing this by elimination slash addition, you got to make sure that the coefficients of either the x's or the coefficients of the y's are opposites of each other. So you got to pick one of the variables you want to eliminate. Which one do you want to do? You keep saying the first one. I'm not sure what you mean by the first one. You got to say x or y. Don't say first when I ask you that question. Which one do you want to eliminate? The y's? Okay. So this coefficient's a -1. This coefficient's a -3. What's the least common multiple of 1 and 3? What's the least common multiple of 1 and 3? 3. Okay, so since this is already a 3, really it's a -3. I got to make this a 3, right? But they got to be opposites. So one has to be a -3, the other one has to be a +3. Well, since this is already a -3, I got to make this a what? +3. In order to make that a +3, I've got to multiply the top equation by -3. Not 3, -3. And so then I get this new equation that becomes, or the system that becomes, 2x times the -3 is -6x. Negative y times a -3, +3y. 7 times a -3, -21. And then the equation at the bottom stays as it is. Now what do I do? Add them. When I add these, -6x and 6x are eliminated. 3y and -3y eliminated. So that left side is what number? 0. The right side is what number? -7. So what can you tell me? Huh? Okay, so 0 does not equal -7. That's true. But answer the original question. The original question was solve the system. So tell me what can you tell me? There's no solution. Okay, good. You would say no solution. Or you can say the empty set. Okay? All right. Number 3, we're going to do one more, and then we're going to start talking about functions. 2x plus y equal 8, and then 3x plus 3/2 y equal 12. I'm going to solve by substitution. Solve by substitution. Okay? All right, so let's do this by substitution. Which equation might be easier to deal with first? Yeah, the first equation listed, and in the first equation listed, what variable can I get by itself? Easily, the y. So this is going to become y equals what? 8? 8 minus 2x. All right. Now, what do I do with that 8 minus 2x? In fact, the 8 minus 2x. Substitute into the second equation for what variable? Y. So here's what I get. I get 3x plus 3/2 times, in parentheses, what do I put? 8 minus 2x equal 12. So that's where I'm at. Now how do I get rid of the parentheses? Distribute. So here's what I get. 3x. What is 3/2 times 8? Right. 2 into 2 is 1. 2 into 4 is 2 into 8 is 4. 3 times 4 is 12, right? So that's 12. So that's 3x plus 12. What is 3/2 times 2? It's 3. So the question I'm going to ask is, what is 3/2 times a -2x? negative 3x, okay, equal 12. All right, and we're almost done. Combining like terms, what do you get on the left side? You don't get 0 on the left side. What do you get on the left side? 12. What do you get on the right side? 12. So the variables go away, and you have a statement that says 12 equal 12, which is true statement. So what can you tell me about the solutions? Don't say all real numbers. That's not true. You're dealing with a system. Any number that's on the line for any of those equations, right? Either one. So remember, if it's an infinite and there's an infinite number of solutions, if an infinite number of solutions, that means the two equations do what with each other on a graph? They overlap. Remember the word coincide? They coincide. They overlap. So the way we wrote the solution was this: the set of x comma y such that, and then you just list one of these equations. So it doesn't matter which one you list. I'm just going to list the first one. 2x plus y equal 8. All right. So it's not just any point that's in the coordinate plane. It's only those points that lie where? On that line. And how many are there? An infinite number. Okay. All right. Now, before you can do worksheet 3, if you look at worksheet 3 that you picked up, there are the words consistent, inconsistent, dependent, right? So let's talk about that. And then you could then do the worksheet. Okay, so we're going to talk about classification of lines. All right, classification of lines. So when we started talking about systems, we looked at graphs. And in number 1 that we just did, number 1, how many solutions did I have? I didn't have 2 solutions. I had 1 solution, right? It was the point negative 3, negative 3. So I had 1 solution. It was 1 point. That means that if you were to graph these 2 equations or these 2 lines, what would happen in the coordinate plane? They would intersect at how many points? 1. All right. So, number 1. Now remember, we're talking about linear equations, so we're talking about lines only here. There are systems, we're not going to do it in here, but there are systems where they're quadratic. There are systems that could be polynomial instead. All right, but here we're only talking about linear systems. So there's only a few possibilities that can happen. If the lines intersect at 1 point, okay? The lines intersect at 1 point. That means it has at least 1 solution. It has 1 solution. So it's called consistent, and independent. Independent. Consistent and independent. So if it has at least 1 solution, it's consistent system. System is consistent. If it has at least 1 solution, it's consistent. They're independent if the 2 lines are not the same. Each line is independent of the other. Are those 2 lines the same lines? No, they're different lines. They have different slopes, different y-intercepts. Right. So in terms of the solutions, you're going to have 1 solution, right? We're talking about lines now. You're going to have 1 solution. The other kind is if you had, um, if the lines coincided. Lines coincided. So the lines coincided, right? We talked about that. So the lines coincide. How many solutions are there? An infinite number, but there's at least one, correct? Now, when you graphed them, we saw that those two lines were the same line because they did what with each other? They overlapped. It was the same line. So since the lines that coincide have at least one solution, has an infinite number, it's still consistent. So it's a consistent system. Consistent means it has at least one solution, but they're not independent. They are dependent. Because if you look at them, they're really the same line, right? They're really the same line because they overlap. So consistent and dependent. And how many solutions are there? An infinite number of solutions. And then the other case was where we had how many solutions? No solutions. All right, so 3. When we graphed the lines that had no solutions, what did we say they were in relation to each other? Parallel. So the lines are parallel. So the lines are parallel, that means we have no solution, right? So there's no solution, just like when we talked about solving linear equations and there were no solution, we said it was inconsistent. So same thing with system, inconsistent. So if you go back to one of the days, one of the lessons, we talked about consistent and inconsistent. So we had no solution, was inconsistent. All right, so in number one, tell me something about the classification of this system. Say it again? Consistent and what else? Independent. So this system is consistent and independent. So this system is consistent and independent. Independent. So consistent means it has at least one solution. Independent means that they're totally two different graphs, two different equations. Classify the second system for me. The second, number 2. Say it again? Yeah, but classify them. Inconsistent. That's all you say. Inconsistent. So this system is inconsistent. This system is inconsistent. But yes, they are going to be parallel. But I need for you to use the word inconsistent. All right, classify the third one for me. Consistent because it has at least one solution. In fact, it has how many? An infinite number. But what can you tell me about the relationship among the equations? They're dependent. They're the same graph. So this system is consistent and dependent. Okay? Consistent and dependent. All right, so that should help you with worksheet number 3. Worksheet number 3.